For as long as we've been human, we've looked up at the night sky with wonder. But here's the thing, our ability to look at the cosmos has gotten so good, it's actually outpaced our ability to make sense of it all. So today, we're going to talk about a powerful new partner that's helping us sift through the stars to find the universe's deepest secrets. And that partner, it's artificial intelligence.
This right here is the heart of the problem for modern astronomy. It's not that we don't have enough information, it's that we have way, way too much. It's an absolute flood. We've built these incredible tools to see the universe, but we are literally drowning in the data they send back. Analyzing it by hand, that's just not possible anymore.
And I'm not talking about a little wave of data. This is a full-blown cosmic tsunami. So let's really dig into the scale of what astronomers are actually dealing with here. To give you an idea, let's look at the Vera C. Rubin Observatory. Its camera is a mind-blowing 3.2 gigapixels. It scans the entire southern sky every few nights. We're talking terabytes of data and millions of new cosmic events every single night. There is just no way a human team could ever keep up with that. So this data tsunami creates some pretty huge challenges. First, you've got these unbelievable volumes of information. Then you have to find these tiny, complex patterns that are hidden in a sea of cosmic noise. And on top of that, you're trying to track millions of different objects all moving across the sky. And all the while, you have to figure out, is that little flash of light a real supernova, or is it just a glitch in the sensor?
So how do you solve a problem that's basically impossible? Well, you bring in a totally new kind of helper. This is where AI comes in. It's fast becoming an absolutely essential tool, kind of like a virtual astronomer working right alongside the human ones.
And you can really see the difference here. The old way, astronomers would spend years, sometimes their whole careers, manually combing through data, which was slow and, humans make mistakes. But the AI-based method, it chews through massive data sets automatically and super efficiently. And here's the real kicker. It can spot patterns that are literally invisible to the human eye, and it does it with incredible accuracy. This quote really just says it all, doesn't it? A task that might have taken a researcher months of work can now be done in seconds. It's not just about doing things faster, it's about doing them better, more accurately, and unlocking a scale of science that used to be pure science fiction. Okay, so AI is a data crunching beast, we get it. But what are we actually finding with this powerful new partnership? Let's take a look at the incredible discoveries it's already making happen. First up, something I think is one of the most exciting quests in all of science, the hunt for new worlds orbiting other stars. You know them as exoplanets.
All right, so to get why AI is so important here, you first need to understand how we find these planets. The main way is something called the transit method. Basically, we stare at a star and we look for a tiny, tiny repeating dip in its brightness. That little dip could be a planet passing in front of it, casting a shadow our way. And this is where AI absolutely changes the game. It can spot dips in brightness that are so faint, so buried in the noise, that a person would just scan right past them. It can check the data from millions of stars at once, and this is huge, it learns to tell the difference between a real planet and a false alarm, like a sunspot. It's so good, one researcher actually used AI to find over 1.5 million potential new objects just sitting in old NASA data. Okay, let's go from hunting for tiny planets to one of the biggest challenges you can imagine. Taking a picture of something that, by its very nature, you can't see. Yeah, I'm talking about taking a picture of a supermassive black hole. You know that famous first ever image of a black hole? Well, that wasn't taken with just one telescope. It was made by combining messy, incomplete data from a whole network of telescopes all over the world. AI was absolutely essential. It was the only thing that could sort through all that noise, piece together all the little fragments of information, and then use simulations of what a black hole should look like to build a clear picture out of all that chaos. So we've found planets and we've photographed black holes. What about everything else? The next great challenge is to map the universe by classifying the billions and billions of galaxies out there. And this isn't just about cosmic organization. Understanding how galaxies form and cluster together helps us piece together the entire story of how our universe evolved. So what does this look like in practice? Well, every single night, telescopes spot thousands of new galaxies. Then you've got these advanced AI models, like vision transformers, which are basically designed to look at images and understand what's in them. And they analyze each galaxy's structure. Is it a spiral? Is it an elliptical? Then, other algorithms automatically group all the similar-looking galaxies together. This lets us classify the universe at a speed that is just breathtaking, building this incredible map of cosmic history.
So, with all these amazing things happening right now, you've got to ask yourself, what's next? Where do we go from here? Let's look ahead to astronomy's next frontier, which is going to be completely powered by AI. This timeline just shows this fascinating evolution. Right now, we're in this awesome era of collaboration. Humans come up with the creative ideas, the big questions, and AI does the heavy lifting with the data. In the near future, we could see totally autonomous observatories where an AI decides what to look at all by itself and analyzes the results. And then way down the line, well, we could see true autonomous discovery, where an AI comes up with its own scientific questions and then figures out how to answer them. But for now, and for the foreseeable future, this is the main takeaway. This is not about humans being replaced. It's about a partnership. The future of astronomy is this incredible combination, the creativity and the gut instinct of the human mind guiding the unbelievable analytical power of artificial intelligence. And all this technology, all this data, it brings us to one of the deepest, most profound questions we could ever ask. With this incredible new partner analyzing signals from distant stars, peering into the atmospheres of alien worlds, and sifting through data at a scale we could never have dreamed of, we might just have our best shot yet at finally answering that ancient question, are we alone in the universe?